All right guys, welcome back to the channel. Finally getting back started on videos again. Had a little bit of a head cold, still kind of have it, but getting over that. So anyway, he's got a 51 model Chevrolet. It's got I think it's a cast iron LS3, you know, like 376 cubic inches. Stage 4 LS3 BTR cam. So let's go ahead and get this thing inside and check it out. So this thing's definitely got some character, that's for sure. A lot of time and effort into this. Anyways, let's get under the hood, check this thing out. Y'all let me know down in the comments, what do you think? Do you rock this thing? All right, so it says 5.3 LS in the paint, but according to the text message I got, it's essentially an iron 6.2, so 376 cubic inches, got square port heads on it, has a BTR Stage 4 LS3 camshaft, turnstile fuel pressure regulator, poly high ram lower. It's got the lid. This is off like the small block Ford style lids for like a Fox body or something similar, where it runs, especially that Terminator style for the just a 302. So I believe that's what that lid is for. Gen 3 drive-by-wire throttle body, got the Gen 3 style mouth. Everything looks good. I think this thing has a 4L80 in it, but I will check it for sure when I get underneath the truck. All right guys, so built a base file for this thing. Again, it's an LS3. This actually, I did look, it does have a 4L80. After I loaded the base file in there, the truck doesn't really want to start like it's supposed to. So let's see if it'll show you guys how it starts right now. Sound familiar to y'all? Key it off, and it tries to start a little bit better. See how it's still popping though? So anyways, check engine light kicks on, and I'll show you guys what code it is. All right, so we're gonna log into this thing, pull the codes. So ignore the 1637, that's probably on my end. I don't know if this thing is running the F or the L terminal, so I'll get that fixed, but the PO343 is the main concern. This engine does have a cam sensor on the front timing cover, so it's been converted to like the single pole LS2 style front timing cover. So that's where I'm gonna start, is I'm gonna check the wiring and make sure that the extension harness is actually wired correctly. So that's where we start. All right, so 51 is up on the rack. Let's look at the, okay, so if you guys notice, the red wire is on top and the white wire is on bottom. I believe those are supposed to be flipped. I'm gonna check a wiring diagram though. So y'all may be wondering how I arrived at that the wires need to be flipped. But 343 traditionally means that the 12 volt power is actually feeding through the signal. So when it says camshaft position sensor circuit high, that means it's getting more voltage than what it wants. So a cam sensor has 12 volt reference, it's got a ground, and it's got a signal. So usually when these two wires are flipped, that's usually what's going on. So I'm gonna get these wires switched around. As you can see, I just depinned it. I'll push them back in the correct spot. We'll put the lock tab back in there, and then we'll double check the codes. But if you didn't watch my other video where I had the long crank time, pretty much anytime you have long crank time and you key it off and then maybe long crank time again and then key it off and then it fires up, what it does is it actually flips the firing order. So these ECUs actually have two different firing orders they can reference. So we have the main one and then we have basically a backup one. So that's all it does. It just flips firing order and it starts right up. So anyways, I'm gonna get these wires switched and then we'll check it for codes again. So it's plugged back in and now you'll see the red wires on the bottom where it was on the top. So let's lower the truck back down and see if the code's going. All right, so codes have been cleared. Let's see how it starts now. Fired right up. So we've got high idle. Not real sure what that is just yet. I think this thing may have a vacuum leak because my short-term idle trims, this thing's not running the greatest at all right now. Yeah, short-term idle trims, last time this thing ran, they were like -8, and I feel like it shouldn't be because, I mean, this is a stage 4 LS3 cam, so I've got it set up to where the idle desired airflow should be pretty close. So let's look at idle desired here. No, they're actually matching. I may just be off on my base running airflow. So I'm gonna let this thing warm up and then we'll get underneath it and look the truck over before we put on the dyno. Okay, so I actually noticed the problem. When I built this base file, I forgot to disable the park neutral safety switch. So right now the truck thinks it's in drive. So it's gonna obviously have a lot more idle airflow in drive than it does in park. So let me go ahead and we'll stop the log, keep the truck off, and make make sure the fan's off, and I will show you guys what to do. This is pretty simple. So any of the 4L60, 4L80 combinations, you can actually get them to display park, neutral, drive, all that stuff by actually disabling this. So you just go under, it's under trans, general, and then PRNDL equipped, and you can just hit none. And then I will flash this into the truck, and then we will have a functioning gear indicator on the scanner, and that will allow the ECU to reference the correct base running idle airflow tables. Here, hang on, let me disconnect from the scanner because I forgot. But that will allow your ECU to use the correct base running airflow tables, because right now it's trying just to reference the drive table, and we don't want that. We want the truck to be able to pull airflow when it's in park, and we want it to be able to add airflow when it goes into drive. So we're gonna let this tune load in, and then we'll start to scan it again. Okay, so that tune's loaded in. You'll now see that park neutral shows park. I can actually pull it down into gear, and you'll see it goes to D4. I can put it in reverse, shows reverse, so everything is working correctly now. So now I'm just gonna let the truck sit here and run and warm up. Before I put it on the dyno, I just wanna make sure, because this truck, he said that there was some mechanical issues that he thought needed to be addressed. So right now what I'm actually gonna watch is, I wanna watch the closed loop fueling. Whenever I was doing the data log a few minutes ago, that we had some side to side fueling issues. So it could be an injector issue, it could be vacuum leak. So I'm gonna let the truck warm up and see, like right now you guys can see how big the spread is between the two. Obviously we can't tune bank to bank on these, or we don't need to. So if they maintain this gap, then we may have a vacuum leak. So I'm gonna data log this and I will be right back. So the truck's ran a pretty good amount, and you guys can see short-term fuel trim. I mean, we've still got a big gap. So it's time to smoke test this thing. So the saga on the cam sensor continues. So went through, as you guys saw, changed the wiring up. So the wiring was good, and after y'all saw the truck start up, and it actually had that high RPM startup, that was actually the truck about to throw a PO342, which is cam sensor circuit low. And what it does, the ECU, if it doesn't see the number of pulses that it wants, it will actually speed up the RPM in order to make sure that there's a cam sensor fault. So that's why I had that crazy high idle. So once the truck idled high, it threw a PO342. I was like, okay, let's back up again. So double check the wiring. On these, you have to have a 12 volt reference, you have to have a ground, and you have to have the signal. Wiring checked out good. So then contacted them about the engine, found the engine builder, got a picture of the engine. I'll go in and post right here. But as you guys will see, it's actually got a 4-pole cam gear instead of having the single pole cam gear. So again, with this thing having the front timing cover like that, with the Gen 3 ECU, you've got to use a single pole cam gear. Anyways, customer's going to take it back to the shop with that, put the engine in, they're going to swap out the cam gear free of charge, and then it will come back for a tune. So all I'm going to do right now is, I've started off from scratch on the tune on this thing. So I'm going to just take it up the road, make sure closed loop fueling and idle stuff is as close as possible so he can take it and put it into a parade. And then once the parade is over, he's going to get it worked on and he'll bring it back. So you guys will see the final tune up on this thing, but it's not going to be now, it's going to be later on down the road. That's it for that. So I'm going to pull this thing off the rack and go for a drive. All right guys, so the second car we're going to work on in this video, this 2015 Chevrolet Corvette. This is a Z51 automatic car, and this car supposedly was upgraded by LMR and has their camshaft, headers. Basically, he was saying it's like their 630 horsepower package. Now, I have personally never seen an LMR 630 package that was in a C7. I've seen their packages where they add, 85 to 100 horsepower or 130 horsepower, whatever, but that's what we're working on. So the customer purchased this car just like this. So we're seeing, instead of long tube headers, we've got an AFE cold air. We do have a camshaft that is unknown. So again, it's supposed to be LMR, but we will see. So otherwise, looks like the car is pretty much stock. So what we're gonna do is we're gonna data log the current tune that's in this car and take a look at the torque model and zero pedal torque and idle timing and things like that, and get an idea of the mechanical condition that this car is in currently. So let's go ahead on, jump in and fire this thing up. All right, so we're in the C7 now. Again, we are on the tune-up that was in the car. Customer said that this was modified by LMR, but I don't necessarily know if this is an LMR tune, so I'm not gonna say it's that. I honestly feel like maybe they had tuned it originally, but then somebody else has gotten a hold of it from what it seems like. Long-term fuel trims are chilling at 0. See where we're at zero pedal torque wise. Zero pedal torque is higher than what it should be. Now, as the car warms up, if it comes down to 0, we'll be okay. Car's got a reasonable amount of timing in it as far as ignition timing goes. So far everything looks good in the data log from what I'm seeing. Now again, I don't know who tuned this. I'm gonna assume that it was LMR originally, and then that another shop's had their hands on it by the look of it, because some of what I see doesn't make sense and some of it does. So I don't want anybody to think that I'm calling anybody else out. This is basically what I do as a tuner: is the car come in, customer purchase it, camshaft is unknown. So the best place to start is just data log what it's got now. The customer didn't necessarily have any complaints about drivability. He actually didn't know. I think somebody had talked him into trying to plug in like one of the range technologies, like the DoD disablers, into the WD2 port for some reason, and apparently the car started to act screwy. I don't know, it's just the story that I've been told. I don't know. I honestly think at this point they just want me just to retune it, just to double check everything. So I'm gonna want to start from scratch. But again, how they did this tune-up is not necessarily incorrect. The only thing that I know for a fact is incorrect is if you guys look at my MAF and Dyno versus VE airflow, that is showing you that we are pretty far off on the VE table, because the VE table in this car is still factory. So that is incorrect. So yeah, so we're 40% off on the VE table right now. So that we do know for a fact is bad. Technically what I could do is I could leave everything else alone in this tune-up as of right now, and we could actually tune it we could just start where they left off and tune it. I'm not gonna do that, but we could. And if you guys want to see how we calculate VE airflow and how I'm doing this air on the VE table, I do have members only videos that are up. You have to be a silver member or above to see these videos. The silver membership's $9.99 a month, but what it's going to give you access to, it's going to give you access to the stuff that nobody else really teaches. So I have 2 videos up right now. There will be more. I'll have another one coming out this week. But basically the first couple videos are going to be on how to calculate VE airflow when you're in MAF only mode. And it also shows you how to tune your VE table while in MAF only mode. So it makes the tuning process so much faster, but I don't think anybody has it in any of the tuning books or any of the tuning videos. So if you guys want to check it out, again, it's $9.99 a month. And I try to bring everybody the value where it's, I mean, honestly, with the formulas that I showed my first 2 videos, I'd have paid somebody $1,000 back then to be able to show me this stuff. I mean, I have saved so many hours of tuning VE tables by doing this setup. But anyways, car's warming up. It is warming up a little bit slower than normal, which it is cold as shit outside. Like he's got the radio in valet mode. I don't know, I think it's like in the 40s here right now, which is kind of crazy for Tennessee as early as it is in the cold season. The car, I believe it's got a 180-degree thermostat, so maybe that's why it's taking so long, but we're up to 162 degrees now. Let's go ahead on and pull up their tables, and I'm gonna just put a background stock tune in the background. All right, so idle, it's kind of high. I mean, I'm kind of surprised. They've got this camshaft idling at 900. It's making all the idle vacuum. I mean, we're literally sitting at 50 kPa. So I feel like this camshaft could be idled down quite a bit. Let me see if this thing's got a torque converter in it. I almost feel like it's got a torque converter, because we're literally idling at like, almost 900 still. And it's not really pushing on the car. I mean, if I let off the brake, the car lurches, but it's not like terrible. So anyways, I could bring that down some, or we could try to. They didn't modify the Axie on idle torque reserve. So if you guys are curious about like how I do the Gen 5 idle stuff, I'll go on and link a video up here, but it'll kind of give you an idea as to what I do on Gen 5. But basically on Gen 5, I would just modify the Axie. So say I've increased idle RPM 200 RPM over stock, then I would move up my Axie 200 RPM, and that would just kind of bring everything else in line. And same with this external load, I would just move the Axie up 200 RPM. I would bring all the other stuff back down to factory. So again, I have a little bit different way of doing it, but their way is working, so more power to them. But looking through the speed density tables, you guys can see that the coefficients are all factory, so the VE table is stock. Variable camshaft, they left it enabled as 1, but they just zeroed out the tables here. I mean, I guess it works. It just, to me, it's easier just to flip the switch to none. Back in the day, guys on the forums would say that turning it off to none would cause some weird issues, but I haven't found those issues yet at all, actually. When you switch it to none, it no longer references like the VCT timing table and all that stuff, so it just makes it where there's just a lot less work you have to do, honestly. And you're telling me the truth that there is actually no variable cam timing. But yeah, I mean, pretty much, like I said, I already looked through here. The only other things I noticed is if we go to the torque coefficients, you guys can see where they just pretty much just reduce torque across the board. You just don't do that. I'm gonna go ahead on and start working on the base file. Again, if you want to see how I do my base files, you can just go back to that link that I just posted just a little bit ago. It is on my page. It's like a how to Gen 5 startup tune or something like that. You guys can check that out. So I'm going to modify this base file and go ahead on and get this thing up onto the 4-post and get it up on the dyno. All right, guys, I had to go on and film this. So went ahead on and went to load my base file in. Car acted like it didn't want to start. So I was thinking, okay, maybe I corrupted the file somehow. So let me go back to what was in it and go start the car, and this is what it sounds like. So right now it's acting like it doesn't want to start. I'll let the key off. Here, let me go and close the door. That way nobody says, oh, it's got the door open. And it just nothing. I mean, just cranks, sounds like complete shit, and just nothing. So usually when I see this, I'll go on and tell you that usually it's because it's got like one of those throttle response things. I forget what they call them, but like the pedal commanders. So let's go ahead on and I'm gonna check it, but it's showing engine power reduced. It's showing all the normal signs of it having a pedal commander. All right, so the story lines up now. Look at that. No idea what that is. You see where it's tied into the pedal. So every time I see anything installed on the pedal, which I'm assuming that's some type of pedal commander or something or other, but anytime something's stuck in line, wired into the pedal, you will always have an issue if you clear codes, if you do anything. So now it makes sense as to, I mean, obviously I'm not real sure why he tried to plug in that in-range module, but either way, he tried to plug in the in-range module and the car started freaking out. That's exactly why. The in-range module triggered something in the ECU, just like what it does whenever we have like when we're flashing it, and it goes into this reduced engine power. So the fix for this is actually just gonna be remove that pedal commander or whatever the hell it is. So I'm gonna go ahead and remove that and we'll get the car up and running. All right, guys, so got the base file loaded into the car now. Just made a kind of quick V table change and it looks like I went too far. So again, I'm not sure of what the camshaft is, but I assumed with them having it idling at 900 RPM that it was bigger than what it is. So I used a V table I just used like my GPI SS3 base V table. So it looks like we're actually in between stock and an SS3, which is, I mean, simple enough. I can make that change. So you'll see that now V airflow is actually low and roughly 32% in the opposite direction now. So not a big deal. I'll make a change there. Virtual torque. Actually, right now we're on the stock torque model with just my changes to the axis and idle RPM because I want to kind of get an idea as to what I need to make for torque wise. I also need to make sure that the math is close. So I'm gonna let it run a little bit more, but it looks like I'm a little bit off on closed loop fueling. So before I make a 0 pedal torque change for the torque model, I'm going to correct the math and correct the V table first. And then once these three numbers are in line at idle and our short-term fuel trims are plus or minus 2 or 3% at idle, then I'll start to look at the 0 pedal torque. But as you guys can see right now, the ECU is adding between 18 to 24 foot-pounds of torque, meaning that's why it's pushing this idle timing up as it's trying to use timing to add some torque to the car to keep it alive, to have it towards idling correctly. So I'm gonna go ahead on and make those changes, but after unplugging that pedal commander thing, it's actually the Vitesse, whatever it is, Vitesse Motorsports. It's garbage, it's all garbage. You guys, I know some of you guys want better throttle response. I promise you can do it in the tune file. I actually gave some tips on how to make that change in the tune file in the video, my first how to do the Gen 5 startup video. I may show you guys again on here if this car needs it. A lot of times the 8 speeds really don't need a throttle response increase once they're tuned properly. Like as far as if the V table's correct, math table's correct, timing is correct, usually they don't need any more throttle response. Sometimes they'll actually get a little bit jerky on the interstate. But of course you can also adjust throttle response by gear. So I can make it maybe a little bit more peppy in first gear, but I'm gonna go ahead on to make these changes. It looks like I'm gonna be roughly 10% off or so on the math, which is not a big deal. I actually am still using the original math curve to this car. So I'll make that change and correct the V table and we will log it again. So that change has been made to where we're closer on the math for closed loop fueling. Again, we're cruising in math only mode and I'm gonna be tuning the V table at the same time. So I went ahead and added 25%, which would roughly put me at where like a 220 BTR cam or like one of the smaller like GPI SS1 cams would be, and I'm much closer now on V. So I'm gonna assume this camshaft probably has between 217 degrees intake duration to maybe 220, 221 intake duration is where this V table is lining out. We have a stock intake manifold, so it's pretty easy for me to come to conclusions like that. 0 pedal torque has been increased. So now we are up to, the car is adding between 30 and 35 foot-pounds of torque to it. Idle timing is starting to come back into where it should be. So I'm going to make another V table change. And nothing crazy, as you guys can see, around 750, I'm 8 to 9% off. At 1,000, I'm between 3 and 2% off. So I'll make that change, and then I'm going to go ahead on and subtract some idle torque from the torque model, and I will show you guys that. So I'm going to stop this data log, and we'll go ahead on and jump into making our torque model adjustment. And actually, it looks like it's between 24 and 34 foot-pounds. So, all right, so to make our change, we're gonna go to edit, we're gonna go to virtual torque, and what I wanna do is, right now I'm commanding at roughly 850 idle. So we're gonna kind of be in this area, but we're gonna make this change from 550 to 950. And what I'm gonna do is, as I talked about in my other video, you wanna kind of do this in small steps depending on what your zero pedal torque is. So right now, zero pedal torque is, we'll just call it 30 foot-pounds. So what we're gonna do is, let's go on and subtract, what do I wanna do for 30 foot-pounds? Let's do 15% reduction. So anyway, so at 0 on cylinder air mass, we are running negative numbers. So in order to lower a negative number, we're gonna actually need to add or multiply by a positive 15%. So we're gonna do 1.15 and we're gonna hit multiply. Now these tables are linked together, so you'll see this link selection is checked. That's how yours is gonna be right off the bat. That's got that handled. So what we're gonna do is we're gonna scroll down to the bottom. We're at 800 milligrams on cylinder air mass. We're gonna highlight from 550 to 950, and we're gonna do multiplier times 0.85. And then we're going to highlight 550 to 950, and we're going to interpolate vertically, and we're going to extrapolate coefficients. We're going to do the same for map, so exact same way. Actually, since the multiplier is still at 0.85, we'll go down to the bottom. So 0.85, we'll go to the top, 1.15, highlight, interpolate vertically, extrapolate coefficients, and we're gonna do the same thing for the E85 tables. So that's what we do on all 4 tables. We're gonna do the exact same changes. Now, again, like, it's been a while since I've had to essentially tune a torque model from scratch, because I do tune these cars so much that I have base files for pretty much every camshaft. But once I have a camshaft that's unknown to me, I have to basically use the data to actually figure out which camshaft is in the car, which is not a big deal. I will have to do the same thing to figure out if this thing's got an increased fuel load. So I'll watch the PID on the high pressure fuel pump and determine what size fuel load we've got. But now that the torque model adjustments have been made, I'm going to go ahead and load this into the car. Now on a Corvette, if you guys don't know, or anything with the push button keyless entry, to go into Diag mode, you just no foot on the brake whatsoever. If it's a stick shift car, no foot on the clutch, and you'll push and hold it for like 10 seconds, and that'll activate. That's basically like turning your key to the ignition on. If you push it one time, it'll be in accessory mode, which is fine. You can flash through accessory mode. But sometimes if you are, I've got to disconnect from my scanner. Sometimes if you're flashing engine, trans, and like the chassis control module, sometimes the key will power down, or accessory mode will power down during a flash, and you don't want that to happen. It's not going to brick anything. The only time you'll ever get one to brick like that is if you're working with T43 TCM, which is the 6L80 TCM. If that loses ignition power after it's done in racing, you pretty much call that TCM bricked. Sometimes you can bench flash them and get them fired back up, but most of the time they're just bricked completely. So if you're working on a 6L80 vehicle, whether it's a car, whether it's a truck, make sure you're always key on. If it's keyless entry, like say you're working on like a 15 model Yukon, push and hold down the ignition button until the gauges power up. That's key on, and that will stay on for I think up to like 10 or 15 minutes. So you're good there. This tune file is loading in. So once this tune file is loaded in, we're gonna start it up and we're gonna double check torque model. So our V table should be even closer. MAF table should be even closer. I subtracted 1% off the MAF at that specific frequency. I'm not touching anything else, and torque model adjustment has been made. So again, we did the 15%. So let's see what 15%'s got us to. I'm gonna say that we're probably gonna be pretty close on zero pedal torque at 15%, but I don't know it for a fact. And apparently this car just set off an alarm. That's funny. I mean, it's loud, but I feel like it's not that loud. All right, so let's pull up Dyno Air versus VV Air, and we're gonna give it a minute to settle in. I actually made the 8% adjustment and the 4% adjustment, so cars sometimes will take a little bit just to settle in. What they'll do is they'll start up and they'll go ahead on and they will look at, you go under airflow, dynamic, and this V correction factor initial. If you guys look, you'll see this table is populated. So because we're at baro roughly 100 kPa and our engine coolant temp is kind of warm, you'll see where it's actually altering the V table slightly on initial. So sometimes the V table will be off just a little bit, but you guys can see it's already starting to pull in tighter. See where zero pedal torque is. Zero pedal torque is pretty much dead nuts on the money. So we're fluctuating between -6 and 6. Just like the trucks, the automatic Corvettes like to idle at roughly 0 foot-pounds of torque on average. So if you look at engine torque right here, you'll see that we're averaging, 0 to 6 foot-pounds. Same with right here. So we will call our idle good. So you guys will see that our idle has stabilized, timing is doing its thing. I'm gonna leave the idle in this car a little bit more choppy because honestly with the camshaft being kind of small, I'd hate to smooth it out too much, but just know that you can smooth this out some more if you want. I mean, this car is, if I smooth it out too much, it's just gonna sound like a stock C7, so it's not worth it. Right now we're on the same spark correction table as GM would have it from the factory. If you guys are curious what that looks like, we're gonna go under idle, and it's under adaptive idle. Anytime you see immediate is timing control, predict is airflow control, like your throttle blade angle. So this table right here under immediate, this is basically telling you how much timing it's subtracting. Now this is not in timing degrees, this is actually in foot-pounds. So what it's going to do is it's going to reference your torque model to understand what 1.84 foot-pounds is, but this is where you get essentially the chop from. So if you wanted to reduce the amount of timing swing, you could actually take this and like half it, or times 0.75 or something like that, and you will reduce it. If you want to increase timing swing, you would multiply by a positive number, like multiply it times 1.5 or 2 or whatever. But I try to leave as much stuff close to factory as possible unless it's necessary. So if this was an older gentleman or an older lady or somebody that just didn't want to hear it chop, like if we want to try to disguise this car having a camshaft, I could go in there and smooth it out, but this customer is going to want it to have a little bit of rowdiness to it. But as you guys can see, V table is settled into where it's pretty much spot on. Again, like I talked about in other videos, please don't sweat the like 0 to 10% stuff. GM from the factory doesn't really sweat it as much either. They try to get everything as perfect as possible, but you're never going to get it 100% perfect. So what I'll do is once I'm actually doing the steady state stuff on the dyno, I'll try to make sure everything's plus or minus 5. Now, of course, me being OCD, I do try to get plus or minus 2, but I'm not going to spend all day on trying to get it plus or minus 2 because I know tomorrow it's not going to be plus or minus 2. So from that point, idle looks good, everything looks stable, car's running happy, throttle controller or whatever that bullshit was has been taken off. So now I'm going to get it up on the rack, get the wideband in there, and we'll get to tuning it on the dyno. All right, guys, we're up on the dyno and the C7 Corvette. About to start doing the vehicle simulation pulls. I haven't made any changes to this thing other than what you guys have already seen. So let's go ahead and put this thing in a drive, the MAF. So first off, if you just saw that, this car has the pause when shifting into drive. That's just one of those 8L90 things that, I mean, realistically, it probably needs some transmission work. Nothing I can do to fix that, so it's probably going to catch me off guard a couple times like in this video. MAF curve and everything is basically where it was at before. You guys can see my V table is off in the areas that I have not made adjustments, but MAF looks like it's actually like pretty close. We'll go down to manual mode, we'll paddle down. So right now I'm just taking the data on the V table itself. Everything looks good, car's warmed up. I'm actually going to paddle down to, let's go fourth. And I'm actually going to go ahead on and do a wide open throttle hit. If air fuel ratio stays good, then I'll probably stay in it, but if it starts to veer off, I'll lift. So we had a little bit of a traction issue there, so I just went ahead on and stayed in it to get the tires warmed up. You guys could tell us pretty much as soon as the tires got warm, the car gripped up and everything was good. So it looks like we are rich, but nothing terrible. So right here we're 84 lambda, and I'm commanding roughly 88. So I need to pull some fuel out of it. Seeing a little bit of knock right here. So not a huge deal. Could be fuel knock from being a little bit rich. Otherwise the car sounded pretty good. V table is not as far off up top as I thought. So you guys can kind of get an idea of where I'm at V table wise. Why is the P ratio going down so far? So MAP is going down to 96. Where's Barrow? Switch over to KPA. Oh, Barrow is climbing. Well, we know that's incorrect. So I will make a change to the car to correct this, because Barrow showing 106 KPA when it's not 106 KPA is throwing off P ratio, which is going to throw off the V table, which is going to throw off the torque model. It throws off everything. But otherwise, everything else looks good. So what I'm going to do is I'm going to make a fuel change off the MAF curve. I will probably leave V alone up top, and I will just make the changes that we saw as I was kind of sweeping through stuff, like these changes right here. So I'll go ahead on and make those changes, and I will come back and we will do another rip. All right, so made the adjustments to the MAF, went ahead on and tweaked the V table a little bit more. So just baby steps on that kind of stuff. So we're gonna get this thing back up into fourth gear, and I will do another rip on it. I did lean out the car whenever I made the MAF adjustment, so hopefully that'll clear up some of that knock that we were seeing. If you guys don't know, DIs don't like to be rich, so you'll actually get some fuel knock, so you actually want to lean the thing out. Now we're not getting like crazy lean, but you want it leaned out. So everything else is looking good, so let's go on and do a rip. Good solid pull. I'm running 4th gear with the eddy brake on, so I like longer pulls. I tried to make the change to the barrow, but the barrow is still climbing. I was trying to resolve that. Okay, I will try to make another change. Now, I will say that when I looked in the tune file of this car, they actually had the barrow performance code disabled. So maybe the car actually has a MAF issue. I mean, I'm not seeing any problems with the MAF itself. Everything looks to be doing good, but I don't like that barrow creeping like that. We're definitely not getting 105 kPa at the airbox. Like, this thing would be a freaking blast if it was getting that almost pound of boost in it. So anyways, you'll see we got some VE changes need to be made. I could probably tidy up the EQ error versus MAF table a little bit more. I mean, you'll see for the most part I'm within 1%, but that one is one that I'm a little bit extra critical on myself about just because. But also, if you guys notice, knock retard would be in yellow, and that hit, we had no knock retard whatsoever. So that is good. So I'm gonna make these couple more adjustments, and then we'll go ahead on and do some dyno pulls themselves. I can actually do power pull. Again, that was just vehicle simulation, so I have no idea what kind of power it made. So we will do that here in just a second. All right, so dyno is set up. I'm gonna do 5th gear, eddy brake turned down, and we're gonna do a 3,000 to 6,600 pull. This transmission. All right, let's let it rip. All right, so scrolling through the data. Also, I made EQ actual a different color. That way, maybe it'll help you guys see it. It's like went in just a touch rich. For the most part, it looks like we pretty much nailed 0.88, which is what I'm commanding. So a little bit of a fuel adjustment, nothing crazy. No knock, everything looked good. So I'm gonna get out and let's see what kind of power it made. All right, well, in the words of David Freiberger, just kind of a pooch. First pull, 400 horsepower, 367.4 foot-pounds of torque. So for reference, a stock A8 LT1 car on this dyno is in Corvette form. We'll normally do like 360 to 365 wheel. So we're talking right now, this thing's only picking up, 30 to 35 horsepower stock, and it's got long tubes and it's got the AFE intake. So, I mean, I know I'm probably a little bit light on timing. This thing's probably gonna want maybe 1 or 2 more degrees at most, but I'm not that far off on tune-up. So maybe this camshaft is more of a smaller intake duration and maybe just an aggressive LSA, that way it sounds choppy. So just as of right now, I'm not impressed. So just also for reference, when I do something like a say a GPI SS3 and like a 6th gen Camaro, they'll normally get up in the like 480 to 500 wheel range on this dyno. So this car is she's definitely down. So I'm not sure what that's all about, but we'll put some more timing in here. I mean, hell, maybe it picks up 10 horsepower per degree. I kind of doubt it, but maybe. We'll see. But, and also, if you guys are new, this is a Mustang dyno, so this would be like 440 on a Dynojet. So that way you guys can kind of compare it to numbers that you've seen. But this thing is definitely low. So it's, as of right now, it's all bark and no bite. All right, just so you guys can see it, whenever I'm gonna add timing, like this is essentially what my base timing table looks like for one of these. We can pull up 3D if you guys wanna see it, but that's what one of my standard timing tables are gonna look like for, a small cam C7 like this. So if I wanna add some timing, I'm just gonna come over here to this table right here. And this table is only active when in power enrichment. So it's just a good spot to add timing. So what I'm gonna do is, let's say from, I guess I'm kind of light, pretty much everywhere from like 3,600 up. So we'll go 3,600 up. Just gonna stab 2 degrees in here and see if it picks up a bunch. Just wanted to show you guys that. It's just a simple way of adding timing. A lot of guys don't utilize their multipliers, but you really should. Like, they make life so much easier, and it makes more sense too. In case y'all are wondering, I get a lot of these cars like this where the customer buys it, we don't know what's done to it. I got a 6th gen Camaro outside I'll be tuning on probably next week, I guess. We'll do it on camera too, but it'll be the same thing where we're trying to figure out what camshaft's in it. It may make a ton of power, it may not. So I hope you guys know that as I start to make more and more videos on the Gen 5 stuff, I'll show you the cars where they actually make power like they're supposed to. It's just obviously this is not one of them. 2 more degrees is added. Let's try another rip. Kind of glance back in the rear view and notice that it seems like we're getting quite a bit of visible smoke. So I'm gonna check the video and make sure it's not detonation. Could be. I mean, we did just put 2 degrees in there, and like I said, I don't think it's necessarily gonna want it, but I gotta try it anyways. We gotta try to see what's the deal with the power. But anyways, top out, check for power, and I'm going to watch the video of the tailpipe on this car. All right, well, as expected, didn't pick up shit. 402.7 horsepower, 370.9 foot-pounds of torque. So those 2 degrees that I added were completely invalid. But let's pull up the trace and see. I mean, maybe it picked up elsewhere. All right, there's your comparison with the 2 degrees. So a little bit lighter of lines. So I mean, it's not worth it. I'm just gonna pull that timing back out. All right, just so you guys know, I'm gonna try one more pull. Don't think it's gonna pick up anything, but I pulled that timing back out. So we should be back down to the 400 number. And then what I did was actually reduced injection timing. Basically what I'm doing is I'm looking at our fuel window, and injector pulse width is, I mean, it's kind of lowish. And so I'm watching the split, and the split, like this car is going to want roughly 180 degrees split, and we're just off target. So I'm going to pull a little bit of injection timing and see if it picks up some. This is just going to be a test with this camshaft. Most of the time when I try a fresh camshaft, I'll go on and work through injection timing and find MBT for injection timing, but obviously we don't know what cam this is. So I'm just going to kind of blindly shoot at it and see. I'm basically going to use my injection timing table from like a 220 BTR cam. We'll see if it picks up. I have no idea, but let's try it. So I'm gonna load this in. And just so we're aware, I'll probably cover injection timing a little bit more, but with the LT stuff, basically what we're doing is we're trying to make sure that we're not missing our injection target. So with this car being naturally aspirated with what I'm assuming, according to the PID settings, is a little bit larger of fuel lobe, pulling a little bit of injection timing could help. But anyways, I'm lowering the numbers with this specific car. Looking at the split, it should actually pick up some. It should clean up the tailpipe a little bit, but know that I would increase numbers if I was trying to stretch out the fuel system even more. That's probably the best way I can put it. So anyways, tune's loaded in. Let's go ahead on and do a rip. Also, Gen 5 cars, after you flash it, when you key it off, sometimes the starter will hit and it almost sound like the car's locked up. It's not. If you open the door and disconnect from it, then it won't do that every time, but I just let it it'll click once and I'll hit the key off and then I'll start it back up again. It's completely fine. Just understand that's normal. Dyno's set up and ready to go. We're still going to continue this 3,000 to 6,600 in 5th gear. 5th gear is 1.27 to 1 gear ratio. I don't like doing 6th gear pulls on NA cars, and I don't like doing it really with vets in general. This car's a 273 rear gear, so with this tire size, if I were to try to do a 6th gear pull, we'd end up crossing 200 miles an hour. And hard on the dyno, it's hard on the drive line. There's no sense in beating the shit out of the car to get it to show a number where it would probably pick up another 10 to 15 foot-pounds of torque and maybe a couple of numbers on horsepower if I run it in 6. Again, I'm tuning the car. I don't care what kind of power it makes. I just want the car to run like it's supposed to. Camera's going, we're in 5th. Let's start the test. As you guys can see, wideband is basically spot on the entire time. I mean, I'm off 0.5%. I'm not concerned about 0.5%. So let's get out and see if the car picked up any power. All right, so it picked up almost 5 horsepower. So nothing to write home about, but it did pick up power. And of course we are making it more efficient because this is with 2 degrees less timing. So when we made that 402, we actually had 2 degrees more in it, but tailpipe looks clean, fueling looks good. So this is where we're gonna send it out. So I'll show you guys, it's showing pretty much right at 500 flywheel, which is just, I mean, it's just low. It really is. So again, this camshaft, according to the V table and everything else, I'm gonna assume it's between 215 degrees intake duration to 220 degrees intake duration. It may just not have a lot of lift. I don't know what lobe separation angle is. I'm assuming it's kind of tight, but you know, just by the sound of it, and by the shape of the dyno curve, but that's where we're ending up. So that's gonna wrap it up on the C7. I'll take this thing off the dyno and take it out and drive it, make sure everything's okay. Transmission wise, pretty much with this car, I'm gonna leave shift points fairly close to stock. I will delay the torque converter a little bit, and I will raise the shift points pretty much as a whole up just a touch. Nothing crazy. I'll reduce shift time, just kind of the stuff that I showed you in like the 6L80 video. 8L90s are very, very similar in how they react. So as you guys saw, V tables in check now, torque models in check now, everything seems to be happy. So that's essentially just how we work on an unknown cam. So what we'll do is, again, I've got a 6th gen Camaro. I think it's a 2016 model outside. It sounds like it's a little bit larger of a camshaft. Again, customer bought the car, has no idea what's done to it. So we'll go through that one next week, and I will try to get a little bit more in depth into the Gen 5 stuff. But again, with a car like this, no, I don't think there's any mechanical issues. It could just be that it's just a little baby cam, but according to the data, everything looks good. So I'm just doing the best I can with what I have. And that's honestly, if you're going to be a tuner, that's what you've got to understand, is as long as you got no misfires, car drives like it's supposed to, air fuel ratio looks good, timing looks good, everything looks good, we do the best we can. That's all we know what to do. So anyways, guys, thanks for the likes, the comments, the subscriptions. Again, I have my memberships available to where silver support and above, you get to see the members only videos. And in that video, you'll see where I was using the V airflow calculation and how I was dialing in the V table for that. So I'm gonna drop another Gen 5, probably more specific members only video in a couple days. I'm gonna do it to where we'll set it up for P ratio, and I'll show you a couple other things. So if you guys wanna do that, again, it's $9.99 a month, or you can do the $49.99 a month and actually be able to email me and talk to me back and forth and ask me advice and things like that. So anyways, guys, I will see you guys maybe tomorrow. Tomorrow we're actually gonna work on Rich Rules' Turbo LS Crown Vic. Oh, it's gonna be on a Holly. So that'll be on the dyno. We're gonna turn it up as high as it'll go, as long as we don't run into any mechanical issues. And then Saturday, we're gonna take it to Beach Bend and drag race it. So if you're local to me and you wanna come hang out at Beach Bend, we'll be there in the Turbo Crown Vic, and we're gonna shoot for, I like to say, I think do a 10. I mean, it's literally just a turbo 4.8. It's got a next gen, I think it's a Gen 3, 7875 on the 85. Engine's unknown, torque converter's too tight, and it's gonna be on a street tire. So 10 second will be cool, but we'll see. Anyways, see you guys later.